Picture this. You're standing on a street corner in New Haven, Connecticut. The year is 1854. It rained 2 days ago, and the road in front of you is a river of mud. Not soft mud. Thick, sucking, boot-stealing mud that comes up past your ankles with every step. A wagon tries to pass. The wheels sink to the axles. The driver whips his horses. They strain and scream. The wagon doesn't move. 3 men have to wade in with shovels and planks to dig it out. This takes 45 minutes. Now look around. This isn't some backwater village in the wilderness. This is New Haven, one of the oldest cities in America, home to Yale University, a center of commerce and education. And its streets are impassable swamps for 3 months out of every year. Here's what made this problem so maddening. Everyone knew the solution. The Romans had figured it out 2,000 years earlier. You pave roads with crushed stone. You lay a bed of large stones, then medium stones, then small gravel, then roll it flat. Water drains through, traffic compacts it. The road becomes harder and smoother with use instead of softer and worse. The technology existed. The knowledge existed. The need was desperate. So why didn't American cities have paved roads? Because of one impossible bottleneck. You cannot pave roads without crushed stone. And in 1854, there was no efficient way to crush stone. Every piece of gravel on every road in America had been broken by hand. Men with hammers, sitting in quarries, smashing rocks into smaller rocks, hour after hour, day after day. A skilled stonebreaker could produce maybe 2 or 3 tons of crushed stone in a 10-hour day. His hands would be raw. His shoulders would ache. His lungs would fill with stone dust that would eventually kill him. Do the math. Paving 1 mile of road requires roughly 5,000 tons of crushed stone. At 3 tons per man per day, that's nearly 1,700 man-days of labor, just for the stone. Before you transport it, spread it, or roll it, 1 mile of paved road required more labor to produce the stone than to build everything else combined. This is why America had almost no paved roads, not because Americans were lazy, not because they didn't understand engineering, because the economics were impossible. The stone alone cost more than most communities could afford. One man in New Haven was about to change that. His name was Eli Whitney Blake, and this is the story of how his machine turned mountains into gravel and built every road you've ever driven on. Eli Whitney Blake was born in 1795 in Westborough, Massachusetts. If that name sounds familiar, it should. His uncle was Eli Whitney, the inventor of the cotton gin. The family had invention in its blood. But where his uncle's invention would help perpetuate slavery in the American South, the nephew's invention would transform the physical infrastructure of the entire nation. Blake graduated from Yale in 1816 and spent the next 4 decades as a successful manufacturer. He made locks and hardware. He built a comfortable fortune. By his 60s, he could have retired to a quiet life of reading and grandchildren. Instead, he became obsessed with a problem that had plagued humanity since the first road was built. The streets of New Haven were his daily irritation. He watched wagons sink into mud. He watched pedestrians ruin their clothes and twist their ankles. He watched commerce grind to a halt every time it rained. And being an engineer at heart, he couldn't stop thinking about solutions. The existing methods for crushing stone were pathetic. I don't use that word lightly. They were genuinely pathetic. The first method was simple manual labor. Stone breakers. Men hired to sit in quarries and hit rocks with hammers. This was the dominant method worldwide and had been for centuries. It produced decent quality crushed stone, but the output was miserable. A quarry might employ 50 men and produce maybe 150 tons per day. At wages of $1.50 per day, the labor cost alone was $225 for that 150 tons. $1.50 per ton just for breaking. Add quarrying, transportation, and profit margins, and crushed stone was a luxury item. The second method was the stamp mill. Originally designed for crushing ore in mining operations, some entrepreneurs tried adapting it for roadstone. A stamp mill used heavy iron stamps that rose and fell in a wooden frame, pounding whatever was beneath them. The problem was obvious the first time anyone tried it with roadstone. The stamps would sometimes shatter the rock, but just as often, they would simply press it into the ground beneath without breaking it. The machine had no grip. It couldn't hold the stone still while crushing it. Output was inconsistent and disappointing. Most stamp mills for stone were abandoned within a few years. The third method was the roller crusher. Two heavy iron cylinders rotating toward each other, squeezing rock between them. This worked reasonably well for soft stones like limestone, but anything harder would either pass through uncrushed, or worse, jam the rollers and break the machine. A piece of granite or trap rock could destroy a roller crusher in seconds. The repair costs ate up any savings from mechanical crushing. I've read the engineering journals from this period. The frustration leaps off the pages. Everyone could see the need. Everyone could see the potential profit. No one could figure out the mechanism. Stone crushing seemed to be one of those problems that machines simply couldn't solve. The material was too hard, too irregular, too unpredictable. Human judgment and manual labor seemed to be the only answer. Eli Whitney Blake disagreed. In 1857, at the age of 62, Blake had what he later called his moment of clarity. He was watching a man crack walnuts at a holiday dinner. The man held each walnut in his hand and squeezed it between a fixed plate and a lever-operated jaw. The shell cracked. The nut fell out. Simple. Blake realized that every previous crushing machine had tried to crush stone from above. Stamps, rollers, hammers, they all pressed downward. And stone, being hard and irregular, simply moved out of the way or refused to break. But what if you crushed stone from the side? What if you held it between two surfaces and squeezed? The stone couldn't escape sideways because the surfaces blocked it. It couldn't escape downward because the gap was too narrow. The only thing it could do was break. Blake spent the winter of 1857 to 58 building his first prototype in a workshop behind his house. The design was elegant in its simplicity. Two heavy cast iron plates faced each other at a slight angle. One plate was fixed, bolted to a heavy iron frame. The other plate was mounted on a pivot at the top and connected to a flywheel at the bottom through a heavy iron toggle linkage. Here's how it worked. Raw stone was dumped into the top of the machine, into the wide V-shaped gap between the two plates. As the flywheel turned, it pushed and pulled the toggle linkage. The toggle linkage pushed and pulled the bottom of the movable plate. The movable plate would swing toward the fixed plate, crushing any stone caught between them. Then it would swing away, allowing the crushed pieces to fall through the gap at the bottom. Swing in, crush, swing out, drop. Swing in, crush, swing out, drop. Over and over, relentless and unstoppable. The genius was in the geometry. At the top of the crushing chamber, where large rocks entered, the gap was wide, maybe 18 inches. At the bottom, where crushed stone exited, the gap was narrow, maybe 2 inches. As rock moved down through the chamber, it was crushed multiple times. First into large chunks, then into medium chunks, then into gravel. Each stroke of the movable plate crushed every piece of stone in the chamber simultaneously. Nothing escaped. Blake tested his first machine in March 1858. He fed it trap rock from a local quarry. Trap rock is a form of basite, one of the hardest stones used for road building. Stonebreakers hated it. Their hammers bounced off. Their arms went numb. A man might produce only a ton per day working trap rock. Blake's machine ate it. The first hour of operation, Blake's prototype crushed 6 tons of trap rock. Not 2 tons per day, not 3 tons per day, 6 tons per hour. In 1 hour, his machine outproduced 2 of the best stonebreakers working an entire day. By the end of that first day of testing, Blake had crushed over 50 tons of stone. His small machine, operated by a single steam engine, had done the work of 25 men. And this was just the prototype. Blake immediately applied for a patent, which was granted on June 15, 1858. Patent number 20,542, the Jaw Crusher. Within months, he had formed the Blake Rock Crusher Company and begun manufacturing improved versions of his machine. The improvements came fast. Blake's first production models were larger and more powerful than his prototype. A standard Blake crusher of 1860 stood about 8 feet tall and weighed close to 6,000 pounds. The crushing plates were made of hardened manganese steel that could withstand the constant pounding without cracking or wearing too quickly. The flywheel was massive, sometimes 8 feet in diameter, storing enough momentum to crush stone on the forward stroke without slowing down. The numbers were extraordinary. A medium-sized Blake crusher, powered by a 15-horsepower steam engine, could crush between 15 and 25 tons of stone per hour, depending on the hardness of the material and the size of the output desired. That's roughly 150 to 200 tons in a 10-hour day. One machine, one operator, one fireman tending the boiler, 3 men total, producing as much crushed stone as 100 stonebreakers. The cost savings were transformational. Where hand-broken stone might cost $2 per ton or more, mechanically crushed stone could be produced for 30 to 50 cents per ton. The price of paving materials fell by 75% almost overnight in areas where Blake crushers were deployed. I want you to understand what this meant. Before Blake, paving a city street was something only the richest cities could afford, and even then, only for the most important streets. After Blake, ordinary towns could pave their main roads. Counties could improve their rural routes. The infrastructure that makes modern transportation possible became economically feasible for the first time in human history. But the jaw crusher was just the beginning. Other inventors saw Blake's success and began experimenting with variations. In 1881, Philetus W. Gates patented the gyratory crusher in Chicago. Where Blake's machine used a swinging jaw, Gates used a cone-shaped crushing head that rotated eccentrically inside a bowl-shaped chamber. Stone fed in at the top was crushed between the rotating cone and the chamber walls, then fell through a gap at the bottom. The gyratory crusher could handle even larger quantities of stone than Blake's design, and became the dominant machine for large-scale quarry operations. The Edison Universal Crushing Company developed cone crushers that could produce more precisely sized output. The Siemens cone crusher, patented in 1920, could be adjusted to produce stone of almost any specific size, from coarse gravel to fine sand. Each development built on Blake's fundamental insight: hold the stone, squeeze it from the sides, let gravity do the work of moving material through the machine. By 1900, rock crushers had spread across America. Every state had quarries equipped with mechanical crushers. Railroads had their own crushing plants to produce ballast for their roadbeds. Cities had municipal crushing operations to produce stone for street paving. The industry that didn't exist in 1857 employed thousands of workers and produced millions of tons of crushed stone annually. Now I want to tell you about those workers, because the story of the machines is only half the story. The other half is written in sweat and blood and early graves. Operating a rock crusher in the 19th century was one of the most dangerous jobs in America. I've spent months researching accident reports, coroner's records, and newspaper accounts from this period. What I found haunts me. The first danger was the obvious one. These machines crushed rock. They would crush anything else that got between those plates with equal efficiency. Men lost fingers, hands, and arms to the crushing jaws. In August 1887, a crusher operator named Thomas Hennessy in Worcester, Massachusetts, reached into the machine to clear a jammed stone. His coworker didn't see him. The steam engine engaged. The movable plate swung forward. Thomas Hennessy lost his right arm at the elbow. He was 34 years old, with a wife and 3 children. He never worked again. The company paid him $40 in settlement and called it generous. The second danger was less obvious, but far more deadly. Stone dust. Every crushing operation filled the air with fine particles of pulverized rock. The workers breathed this dust 8, 10, 12 hours a day. It coated their lungs. It scarred the delicate tissue. It created a condition doctors would later call silicosis, though at the time it was simply called miner's consumption or stonecutter's disease. Men who worked the crushers for 20 years rarely lived to see 50. Their lungs turned to stone. They drowned in their own fluids, gasping for air that couldn't reach their blood. I found the death certificate of William Farrell, age 46, who died in Quincy, Massachusetts in 1891. Cause of death was listed as pneumonia, but his occupation was noted as quarry crusher operator for 22 years. His lungs, according to the examining physician, showed extensive fibrosis and calcite deposits. William Farrell didn't die of pneumonia. He died because he spent 2 decades breathing the stone dust that built America's roads. He left behind a wife, 4 children, and $17 in savings. The third danger was the machinery itself. These were industrial machines in an age before safety standards. Flywheels spun at dangerous speeds, fully exposed. Drive belts could catch loose clothing and drag a man into the mechanism. Steam boilers could explode. The machine didn't care whether it was crushing stone or crushing men. It simply crushed whatever was fed into it. In October 1893, the Wilkes-Barre Times reported that a boy named Peter Kowalski, age 14, was killed at the Kingston crusher when his sleeve caught in the drive belt. He was pulled into the machinery and crushed before anyone could stop the engine. The article was 3 paragraphs long. It appeared on page 6. It mentioned that Peter was the 3rd fatality at Kingston Quarry that year. It did not mention any investigation, any fine, or any change in operations. 14 years old, working a rock crusher, dead before he could vote or marry or see his children grow up. And his death warranted 3 paragraphs on page 6. This was the reality of industrial progress. The machines that built America's roads were fed by cheap labor, and cheap labor meant expendable labor. The men and boys who operated the crushers were paid $1.50 to $2 per day. They worked 12-hour shifts. They had no protective equipment, no ventilation systems, no safety training. When they were injured, they were replaced. When they died, they were buried. When their families needed support, they were told to apply to the Poor Relief Office. I want to name more of them. I've tried to find records, to give faces and stories to the anonymous army of crusher workers. It's nearly impossible. These men didn't leave letters. They didn't write memoirs. They appear in census records as laborers or quarrymen, and then they disappear. A death certificate here, an accident report there. Brief mentions in local newspapers that list their names, but nothing else. But I did find one extended account that has stayed with me. In 1896, a labor organizer named John Mitchell visited several quarries in Pennsylvania as part of his work organizing the United Mine Workers. He wasn't focused on crusher operations, but he described what he saw at one quarry near Scranton. The crusher shed was a scene from the infernal regions, Mitchell wrote. The noise was so tremendous that men communicated only by gesture. The air was thick with stone dust that coated everything and everyone in a layer of gray. The workers coughed constantly. Their eyes watered. Several had tied rags over their mouths and noses, but these seemed to provide little protection. I observed one man, who appeared to be perhaps 60 years of age, laboring to carry buckets of stone to the crusher feed. His hands shook. His breathing rattled. When I asked the foreman about him, I was told the man was 42 years old and had worked at the quarry for 15 years. The foreman said he was one of the best workers they'd ever had. He said this as if it were something to be proud of. 42 years old, looking 60, dying on his feet. And the foreman thought he was lucky to have such a good worker. This is the part of the story that doesn't make it into most histories of industrial progress. The machines were marvels of engineering. They transformed the economy. They built the infrastructure of modern America. And they consumed human lives like fuel. The scale of what happened between 1858 and 1920 defies comprehension. In those 62 years, America went from having almost no paved roads to having a national network of highways reaching every state and territory. Let me give you some numbers. In 1900, the United States had approximately 200,000 miles of roads classified as improved, meaning they had some form of stone or gravel surface. By 1920, that number had risen to over 390,000 miles. That's nearly 200,000 miles of improved roads built in 20 years. 3 miles per day, every day, for 2 decades. Each mile required thousands of tons of crushed stone. The total production of crushed stone in the United States rose from essentially zero in 1858 to over 100 million tons per year by 1920. 100 million tons. That's equivalent to crushing 2 million cubic feet of solid rock every single day. The quarries ran around the clock. The crushers never stopped. The dust clouds rose over every county in America where there was stone to be crushed. The Good Roads movement drove much of this expansion. Starting in the 1880s and gaining momentum through the 1910s, the Good Roads movement was a coalition of cyclists, farmers, business owners, and eventually automobile enthusiasts who lobbied for improved rural roads. They understood something that seems obvious now, but was radical then. Poor roads weren't just an inconvenience. They were an economic catastrophe. A farmer in Iowa in 1890 might produce a bumper crop of corn, only to watch it rot in his barn because the roads were too muddy to transport it to market during the wet season. Businesses couldn't expand beyond their immediate vicinity because shipping costs over bad roads ate up all their profits. Rural communities were isolated for months at a time when the roads became impassable. The Good Roads advocates calculated that bad roads cost the American economy over $500 million per year in lost productivity, spoiled goods, and transportation inefficiencies. That's in $1890. Adjusted for today, that's over $15 billion annually. The solution was obvious: pave the roads. And the technology to do it finally existed, thanks to Eli Whitney Blake's jaw crusher. State after state began establishing highway departments and allocating funds for road improvement. New Jersey created the first state highway department in 1891. Massachusetts followed in 1893. By 1913, every state had some form of highway authority. Federal involvement came with the Federal Aid Road Act of 1916, which provided matching funds to states for highway construction. The results transformed the American landscape. Counties that had been isolated backwaters suddenly found themselves connected to regional and national markets. Towns that had been dying began to thrive again. Farmers who had been subsistence cultivators became commercial producers. The automobile, which would have been useless without roads to drive on, became the defining technology of 20th century America. And all of it rested on a foundation of crushed stone produced by machines descended from Eli Whitney Blake's 1858 invention. I visited a historic quarry in Connecticut last year. It had been converted into a museum of sorts, though museum might be too generous a term. A nonprofit group had preserved some of the old equipment and built a small educational center nearby. The main attraction was a Blake jaw crusher from the 1880s, still intact, though no longer operational. I stood in front of that machine for a long time. It's smaller than I expected, about 8 feet tall, maybe 6 feet wide. The casting is beautiful in its way, with ornate scrollwork on the frame that served no functional purpose, but was typical of Victorian-era machinery. The crushing plates are worn smooth from decades of use, the manganese steel showing the marks of 1,000,000 tons of stone. There was a plaque next to the machine explaining its operation. It mentioned Eli Whitney Blake. It described the mechanics of the crushing action. It noted the importance of crushed stone in road building. It did not mention the workers who operated these machines. It did not mention the dust. It did not mention the deaths. I asked the volunteer docent if she knew anything about the workers who had operated the quarry. She said she didn't. The records from that era were incomplete, she told me. The quarry had changed hands many times. The worker logs, if they ever existed, were long gone. She knew the names of the quarry owners. She knew the dates of major expansions. She knew production figures from annual reports. But the men who actually broke the stone and breathed the dust, they had vanished into history without a trace. This is what happens. The machines get preserved. The achievements get celebrated. The statistics get recorded. And the workers get forgotten. But they shouldn't be forgotten, because without them, nothing would have happened. Eli Whitney Blake designed a brilliant machine, but a machine without operators is just a sculpture. The crushers needed men to feed them, maintain them, repair them, and die for them. The roads needed engineers to plan them and crews to build them. The transformation of America from a wilderness of mud to a network of paved highways was a human achievement, not just a mechanical one. I think about William Farrell, dying at 46 with lungs full of stone. I think about Thomas Hennessy, losing his arm and getting $40 for it. I think about Peter Kowalski, 14 years old, dead in a drive belt, worth 3 paragraphs on page 6. I think about the thousands of others whose names I'll never know, whose stories were never recorded, whose sacrifices were never acknowledged. These men built the world we live in, not metaphorically, literally. Every highway you drive on, every parking lot you pull into, every paved road in America started as solid rock that went through a machine operated by men like them. The gravel under the asphalt is their monument. The smooth surfaces we take for granted are their legacy. The commerce and connection that define modern American life flow through channels they carved. And we don't even know their names. That's the thing about progress. It erases the evidence of its own creation. You drive through Kansas and see endless wheat fields, and you assume it was always like this. You drive through Pennsylvania and see rolling farmland, and you forget that this was once unbroken forest. You take the highway to visit family, and you don't think about the millions of tons of crushed stone beneath your tires, or the men who died producing it. Maybe that's as it should be. Maybe the point of progress is to make itself invisible, to become so integral to daily life that we stop noticing it. Maybe the workers themselves would have wanted that. They weren't working for monuments. They were working for $1.50 per day. They were working to feed their families. They were working because it was the only work available. But I think there's value in remembering. Not nostalgia. I'm not romanticizing the past. Those quarries were dangerous, dirty, exploitative places. The workers were used and discarded. The air they breathed killed them. The machines they served didn't care whether they lived or died. There's nothing romantic about that. What I'm trying to say is something simpler. These were real people. They lived real lives. They made real sacrifices. And the world we inherited was built on their labor. We owe them something for that. Maybe just acknowledgement. Maybe just a moment of recognition that the smooth roads and reliable infrastructure we enjoy came at a cost. Eli Whitney Blake died in 1886, 28 years after patenting his jaw crusher. He saw his invention spread across America and transform the road building industry. He saw imitators and improvers build on his design. He saw the beginning of the good roads movement and the first stirrings of a national demand for paved highways. He was wealthy and respected and comfortable in his final years. I wonder if he ever thought about the workers. The letters and papers that survive don't mention them. His focus was on the machines, on the engineering, on the efficiency gains and cost savings. That was the language of his era, the framework through which progress was measured. Tons per hour, dollars per ton, miles paved per year. The human cost wasn't part of the equation. Maybe it couldn't be. Maybe that's how progress works. Someone has to invent the machine. Someone else has to operate it. And the ones who operate it will always bear the brunt of its dangers. That's been true since the first human picked up the first tool. The inventors get the credit, the workers get the calluses. But here's what I keep coming back to. The machines were necessary. Without Blake's crusher, America wouldn't have paved roads. Without paved roads, we wouldn't have the economy, the mobility, the connected society we live in today. The transformation was essential. The progress was real. And the workers were essential too. Not just their labor, their lives. Their willingness to show up every day and breathe that dust and risk those machines. Their acceptance of conditions that would horrify us today. Their quiet, unrecorded deaths that added up, year after year, into a foundation of sacrifice beneath our comfortable present. I don't know how to reconcile those two truths. The progress was good. The cost was terrible. Both things are true. Both things matter. What I can do is tell their story, or at least tell the parts of it that I can find in the records that survive. I can name the names I've found. William Farrell, Thomas Hennessy, Peter Kowalski. I can describe the conditions they worked in. I can explain what the stone dust did to their lungs. I can make sure that when we celebrate the achievements of American infrastructure, we remember who paid the price. So the next time you drive on a highway, or a paved road, or even a gravel path through a park, think about this. You're driving on crushed stone. That stone came from a quarry. That quarry had a crusher. That crusher had operators. And those operators, whose names have been lost to history, gave their health and sometimes their lives to produce the material beneath your tires. The roads didn't build themselves. They were built by men with machines, by men who breathed dust, by men whose children grew up without fathers, by men whose sacrifices were worth 3 paragraphs on page 6. They deserve more than that. We owe them at least the acknowledgement, at least the moment of recognition, at least the understanding that progress isn't free, that every convenience we enjoy was purchased by someone else's labor and sometimes by someone else's life. Eli Whitney Blake invented the jaw crusher in 1858. It was a brilliant machine. It transformed America. It made possible everything we now take for granted about roads and transportation and the connected world we live in. And it was operated by men who are now forgotten. Men whose dust-filled lungs built the world we inherited. Men whose names we'll never know. This is their story, or as much of it as I could find, or as much of it as anyone thought to write down. It's not enough, but it's something. And maybe that's all any of us can do. Tell the parts of the story we know. Honor the people we can name. Acknowledge the debt we owe to those we can't. The machines keep crushing. The roads keep spreading. the progress keeps happening. And beneath it all, invisible now, are the foundations laid by those forgotten workers, the men who broke the stone that built America.